Good afternoon, everyone. I'm talking about our AI, our applications in Telco, the use cases, and also our Intel's our hardware portfolio and software stack in supporting the use cases. We know that our AI is transformative across industries. So here we show our use cases are in different verticals that we have been working with our customers and partners with. The use cases are in the yellow boxes. Those we identified as more network domain specific use cases, such as like cybersecurity, like network edge analytics, or self-optimized network, and so on. So these are, I'm from our NPG, the Network Platforms Group. So these are the use cases that are, we are focused on are from our NPG. There are also other use cases that are related to network domain, but also our needs are synergy with other verticals, like our smart city, like our autonomous driving, like our retail, and so on. So these are the areas that we're working with other groups, such as IoTG, PSG, our AIPG, and so on, are within Intel. In our network domain, we see our use cases are in two categories. One is around our network core services, like our revenue assurance, like our self-optimizing network, self-healing network, like our service assurance, like predictive maintenance, our network fault, our detection and localization. So there are quite some use cases basically around the network operation. Another category is our kind of like a hybrid network core and edge. So for example, we're talking a lot about edge computing. A lot of applications are, for example, IoT applications, are like our video surveillance, are like our autonomous driving, cars, our drones, robots, our smart manufacture. So these are kind of like related to our computing at the edge. A lot of our media computation, video analytics, image recognition, speech recognition, for example, for our smart call center. So a lot of media analytics, a lot of our machine learning, deep learning are over there. So this is our, what we see as our, our growing our edge computation, our use cases. So the upcoming 5G and edge services we believe that AI will play a key role there. We have seen like a potential and will be our fast growing areas like our industrial control, in our manufacturing, agriculture, and so on. Our smart cities are including like surveillance and information from other sensors, from all kind of like sources, for various kind of like smart functions, right, around the city, in campus, in our libraries, in the hospital, and so on. So our autonomous driving I mentioned, our VR gaming, retail, there is also a transformation of the traditional CDN business. So we anticipate a lot of our use cases, a lot of our data to be generated, to be processed, and AI would be the core our technology over there to drive this. So I talked about the use cases. So and now let's just go to a little bit about the basic of AI. People talk about machine learning, deep learning a lot, but we would say that AI is a big umbrella, and then under this umbrella there are different approaches. Even though we have heard deep learning so much the last several years, but it's just one kind of approach under AI. So deep learning, we know, basically is neural network. And neural network is just one type of machine learning methods, right? And especially deep learning is about our big scale neural network, deep, and large network models, which has proved to be particularly useful to process a large amount of our especially unstructured data, such as our video, image, audio data. So for our applications like facial recognition, like image object recognition, natural language understanding, speech recognition, and so on. Besides deep learning, there are also other methods of machine learning, and now we often call it classic machine learning, or non-deep learning machine learning, or traditional machine learning. Methods like SVM, random forest, are a lot of regression methods, are also unsupervised machine learning, like k-means clustering. There are quite many types, many different methods for machine learning, which basically are use data either labeled and unlabeled to train our mathematical model, to help to do our reasoning or making decision from data. And actually, in the telco domain, we have seen a lot of our problems, a lot of use cases where actually we can use different kinds of machine learning methods to solve the problems. Yet another approach of AI is cognitive reasoning, which is not necessarily you have to build a mathematical or statistical model like in machine learning, but maybe you can build a reasoning system which could be composed of heuristic rules or certain kind of designed procedures. It could be memory based or could be logic based. So that's another type of AI, which can be used for example, for fraud detection, for our certain kind of predictive maintenance, and so on. So in general, we see that for the telco domain, for the different use cases, it could be we can use our methods in any of these different categories, or it could be a combination, a mixture, of these different categories. We believe that AI adoption is just beginning, even though it sounds like everybody is talking about it, and when we are meeting with our customers, and nowadays our AI is always a topic. So we talk a lot about AI, but actually in terms of our AI adoption, we're really just at the beginning stage. Especially in our telco domain, we have seen that almost all our big companies, major customers are thinking about using AI, and there are also quite a number of startup companies are looking into this field. But in terms of deployment, it's still not that many. So I would say the majority of our people are still at our exploratory stage to see how we can use AI. So in Intel, we are working with our customers are, and helping our, our customers in this journey. So this is an overall stack of our, what we have right now and what we can offer to our customers and partners. So at our lowest layer is our hardware. So this is just the computing hardware that we have for AI, not including our networking, our storage, memory, hardware. So just for the computing side, we have our CPUs, our Xeon Core Atom. We have our FPGA, our Area 10, Stratix 10. We have our own GPU, right now, the integrated GPU. In the future, we may have our discrete GPU. So we have our GPU roadmap. We have our ASICs, our large, kind of form factor ASICs to be used in the cloud for deep learning training. We also have very low power ASICs to be used at the edge. Above the layer above hardware is the libraries, the low-level libraries for acceleration. So we have especially our libraries to accelerate deep learning or to accelerate machine learning. We have our own Intel distribution of Python. So these libraries are take advantage of the particular hardware features of Intel platform, so that it can accelerate the speed in many times faster. And then the layer above the library is the framework library. So Intel, we have optimized most of the popular widely used frameworks nowadays, including the popular deep learning libraries like Caffe or TensorFlow, MXNet, and so on, and also machine learning libraries like Scikit-learn, and our Spark libraries like BigDL, MLlib. So we have made a lot of investment here. Many software engineers are doing a great job here to optimize these open source libraries. So all frameworks, all these frameworks are open source, and everyone can get access to them. And then above the framework layer is the platform layer. So for people who don't have a deep background in machine learning and AI, or who are just don't want to spend too much time investigating how to use TensorFlow, how to use the BigDL or whatever, right? So you can just use Intel's the tools the platforms we provide. So for example, we have Intel Deep Learning Deployment Toolkits, which can just take any trained model, models you train from any our framework. So just you take the trained model, optimize the model, deploy the model. So basically, users don't have to be concerned about the framework layer, the library layer, or the hardware layer. We also have our Intel Deep Learning Studio for training. Of course, if you use our reasoning, our system, Intel Saffron, we have the SDK for that. If you use our Movidius, our ASIC for vision recognition, our tasks, you can use our Movidius SDK. So we have a bunch of tools and SDKs for that. And then finally, our highest layer is about the various kinds of use cases in the different domains, right? For 5G, for our SDN, for our autonomous driving, for our smart manufacturing, and so on. So we have having our case studies, POCs, or deployments with customers in these different areas. So a little bit more about our computing hardware. For general AI, which basically I would say non-deep learning AI. So our mainstream hardware for general AI is our CPU. So I would say that we have made a lot of investment and improved a lot the hardware and software stacks for our CPU to be used for AI. And if you need acceleration, we have our FPGA. So we would say for general AI, mainstream is our CPU, and then FPGA for flexible acceleration. For deep learning in particular, there are two sides, the training side and the inference side. So for training, normally training is done in the data center, and then the mainstream training hardware we would recommend to our customers is our Xeon, our Xeon server. So I will show a little bit later, how much progress we have made on our Xeon server for deep learning. And then of course, we also have the Nirvana neural network processor, the ASIC NNP, for intensive training. So basically, our Xeon as our mainstream training plus the intensive training performance from our NNP ASIC. For the inference, again, there are two subcategories. One is to do inference at the data center, and here, again, our mainstream, our inference, our hardware is Xeon. And then the FPGA would be, if you need real-time inference, we would recommend our FPGA as the accelerator. And then if you do inference at the edge, actually nowadays more and more use cases, I also mentioned a little earlier, more and more use cases to do our inference at the edge and gateway. And here working together with our CPUs. It could be Xeon, could be Core, could be Atom CPU, depending on where the inference is done, is on the camera, on the device, or in our base station, in the central office, depending where it is used, right? You may choose different kinds of CPU. And then besides the CPU for acceleration, it could be our integrated GPU for higher inference throughput. It could be our Movidius ASIC for low power visual processing. So for example, for image recognition, for our video detection. So our Movidius chips is around 1 to 2 watts per chip. So it offers the best performance per watt, the best throughput per watt performance. For speech recognition in particular, we have something called GNA. So that is our IP, very low power, less than 1 watt for speech recognition. For autonomous driving, we have, of course, the Mobileye, our system, and we have our FPGA. So it really depends on where you do the inference, the workload, the specific use scenario, you can choose, among this portfolio. So a little bit about our Xeon processor. So here, this is a comparison. The current Xeon, the Skylake, this current generation of Xeon server, Skylake, comparing with the Haswell, our CPU, and also with our software improvement. So now we are in terms of inference throughput, we're 198 times better. Skylake versus Haswell. And then in terms of training, we're 127 times better. We show this because sometimes we got compared, or other people would compare with us using our older generation of our CPU and also using our non-optimized software, we want to say that we have made a lot of progress, both in terms of hardware features and software. So we are, comparing with like the older generation of our products, we have made this significant progress. I mentioned about the libraries. Just get a little bit more detail. So we have, people probably know about our math kernel library, MKL. That is our software, our library product that we have had for many, many years. But recently, we also built something called MKL DNN. So this is a subset of MKL that we made open source, in particular for deep learning usages. So a lot of the commonly used deep learning primitives are optimized and open source, so everybody can get access to the source code. So MKLDNN is very important to use if you use Intel architecture to do our deep learning tasks. Our CLDNN is to support our Intel GPUs. So it's about the same level as MKLDNN, but MKLDNN is more for CPU and CLDNN is for GPU. So the DAAL is a library for traditional machine learning, for supporting like machine learning methods like SVM, like k-means, or random forest, and so on. So MKLDNN is for deep learning, and DAL is machine learning. Our Intel Python distribution, so this is our Intel's version of our Python. It could, if you use our Intel Python distribution, comparing with the our general version of Python, you can get from dozens to even hundreds times of speed up. This is important to know. We also are developing something called Intel ngraph library. So as shown in this figure, so this ngraph library is our abstraction layer between our framework and hardware. So basically, it can work with any kind of framework and then any kind of hardware. So for users, you don't have to worry about what framework you choose. Through the ngraph, it can automatically be your code will be optimized for the hardware underneath it.
Is that also open source?
Yes, ngraph is open source. Yeah, so it's our ongoing work. Yeah, but in our AIPG, or within Intel in AIPG, a lot of software resource is put in there. So that is one of the major investments we're making in Intel to support our AI. Yeah, yeah. So I mentioned about Intel distribution of Python. What I want to emphasize here is that our Intel distribution of Python, you just install it exactly the same way you would install a normal Python. So it's made really very easy. So you just install it instead of a normal Python exactly the same way, and then you will get the speed up automatically. So NumPy, SciPy, scikit-learn, and so on. So these are all have been optimized. So you will see the speed up, significantly. Our frameworks I also have mentioned. I talked about popular deep learning frameworks like TensorFlow, Caffe, MXNet, or Caffe2, CNTK. So we have worked on all of these, and especially for customers, because many enterprise customers use Spark. And then if you use Spark for a lot of your operations, and now you want to add some machine learning or deep learning functions on it, it's not easy for you to use our TensorFlow, Caffe type of thing on top of Spark. So in Intel we initiated an open source project called Big DL. So Big DL is basically to provide our deep learning functionalities on top of Spark. So it has been there for almost 1 year and a half, and it has been very popular. So we are helped quite a number of our big customers in different verticals to deploy it, to use it in production. So yeah, this is something I want you to know. Our AI tools I talk about, we have the deep learning studio, we have the deployment toolkit, we have the Movidius SDK and so on. So so you can just use these easily without knowing the details of the layers underneath. So back to our telco. Within our Intel, especially within our NPG, so our focus area on AI and supported by the hardware portfolio and the software stacks I just mentioned. One area of focus is, of course, network analytics. And then within network analytics, there are a few topics around network operation we're working on. So our one topic is our service quality assurance. Another one is our security analytics. And then yet another one is around our anomaly detection for security. And then another area is for user data analysis. So, the difference between these two, of course, our network operation is based on our network operation data, or telemetry data, especially our telemetry data, our log data, our analysis. While user data analysis is based on the user behavior, our user history data, and so on. So for monetization of the user data. So we have seen our strong demands from our customers for both sides. Another area is around 5G and edge computing, because certainly these are the very hot areas. And we are also actively seeking opportunities to do some POC with our customers in this aspect. So we are possible our topics could be around our surveillance system or autonomous driving, or like a fog computing in our manufacture. And then the third area is around media processing. I mentioned that media analytics is growing pretty fast. We see a lot of use cases. We got a lot of our requests from our customers to get our support there. So for example, for smart call center, voice bot, chat bot, based on speech recognition, based on natural language understanding, these applications are growing very fast, and we need to provide solutions to our customers to support these tasks. I mentioned about our service assurance system. So our Intel, we have built this this stack to collect telemetry, our data for our virtual EPC, for virtual CMTS. So we have collected our large dimension of our telemetry data. And then we want to we're doing our analytics on such data to do our telemetry compaction, so that to identify our small set of features that are related to particular KPIs for KPI prediction, and also for our closed loop, our optimized operation. So this is one topic we are looking into. Another example is around cybersecurity. So Intel, we actually initiated our open source project called Apache Spot. So this is an open source one, so available at GitHub. So this one is basically the inputs are from the log data. So basic get input from several log files, and then set up our Spark-based data streaming and processing our platform, and then we apply machine learning algorithms on top of it. So especially it's based on the Spark MLlib. MLlib is our machine learning library for Spark, and Intel has done quite a comprehensive optimization of this library, so it runs efficiently on our Intel architecture. So we build machine learning algorithms here to detect anomaly in the log file data, so that if there is something unusual or suspicious happening, we can get the alarms. So this is our cybersecurity use case. So we are also actively being involved in some our community activities. So one is the Acumos. Acumos is a Linux Foundation open source platform for AI. So it was just launched recently, actually last month during ONS in Los Angeles. So it was started by AT&T and Tech Mahindra, but right now there are quite a number of big companies already joined Acumos. So basically the goal is to set up our AI platform and marketplace, so that people can different companies can share their data and their models over there. So it supports several. Right now, it supports scikit-learn, TensorFlow, H2O, and the R Cloud. It can take additional popular, commonly used frameworks, so that people can develop their own models. And then contribute the models, onboard the models to the marketplace, and then you can refine models from others, and so on. So it is at a pretty beginning stage, but a lot of things going on over there. As I said, quite some companies have joined. And of course, for Intel, we want to play our important role there, especially by contributing our Intel architecture-based solutions. Another activity is our ENI. Our ENI is a working group under the ETSI, our standard body. So this is our basically activity in building a new standard, particularly for using artificial intelligence techniques in the network management system. So these here are the use cases that have been identified by the ENI members. In 4 areas: network operations, network assurance, service orchestration and management, and infrastructure management. So these are the identified use cases. And right now, ENI is at the stage, where members are making proposals for POCs around these use cases. So at the end, I like to introduce to you, Intel. We have this website called Intel AI Academy. There are tons of very useful information over there. So if you want to learn about our AI, there are classes, tutorials. If you want to use or try Intel our solutions, there are Intel optimized links to Intel optimized frameworks to our access to Intel AI Dev Cloud, or if you want to share your opinion or get some technical support and so on. So a lot of things you can do over there. So very informative place. Yeah, and finally, we are encourage you to use Intel's performance optimized libraries and frameworks. So try our stuffs. We have put enormous investment in Intel in putting together these solutions, in making optimizations on our hardware and software. So please try this, and then and also we're looking for partners to do our POCs and other things with us. So if you're interested, please contact your Intel representative, and so that we can work together in this new domain. Thank you very much.
Thank you.